All right. This is a concavity test. Still on notes for 43. It says suppose f is twice differentiable on the interval I. And that means that A, if f double prime of x is greater than 0, which means that the second derivative is positive, right? If that's the case for all x on that interval, then the graph is concave up. And that's what we were talking about last class period. When it's concave up, the second derivative is negative. I'm sorry, the second derivative is positive. If the second derivative is positive, then the function is concave up. So it's an if and only if type situation. Same thing for part B. If f double prime of x is less than 0, meaning that f double prime would be negative for all x on that interval, then the graph of f is concave downward. So if it's pointing down, that means that the second derivative is negative. If the second derivative is negative, then that means that the function is pointing down or concave downward. Makes sense? Part C, there's a point of inflection. Point of inflection, remember, is the point, the place, or the point where the concavity changes direction. So it's a point of inflection whenever f double prime changes signs. So if I do the test, we're moving into the second derivative test. If I do the second derivative test and I find the x value where the second derivative changes from positive to negative, or if it changes from negative to positive, then that means that that number, that point, that x value is a point of inflection. So let's look at the example here. Example here, y equal x to the fourth minus 4x to the third. Now a and b, we already know what to do there. We talked about that last class period. C and D is moving into concavity, what we want to talk about here. So part C, the intervals of concavity up and down, and they want us to justify. So when it's concave up, that means that my second derivative is positive. Concave down means second derivative is negative. So that means I need to find the second derivative. Well, I can't find the second derivative without finding the first derivative. So let's find the first derivative. So y prime, which would be the first derivative, would be 4x cubed minus 12x squared. Then to find the second derivative, we need to just find a derivative again. So y double prime would be 12x minus 12x squared minus 24x. By just doing the power rule, right? So now that I have the second derivative, I want to find the critical values of the second derivative. The critical values here of the second derivative are possible points of inflections, right? They're possible points of inflection. That's when I find the critical values here. So 0 equals 12x squared minus 24x. All right, so I want to solve this. Of course, I see some common factors in both of those. So I want to factor out, I can factor out a 12 and an x. Okay, so I'm left with x minus 2. All right. So the critical values here, which will make this equal to 0, would be x equals 0 and x equal 2. So those are my critical values, my possible points of inflection. So I want to put that on the number line here. So that's 0 and 2. Right now, remember, all I'm trying to do is try to see if it's going to be positive or negative. All right, so for each interval, and I'm looking at f double prime, and that's this down here. So this first interval, a number that's less than 0, that's a -1. If I plug in -1 here, that's going to end up being a -12, and it's going to be multiplied to, it's going to be a -3. So that's a negative times a negative. That's going to end up being a positive. Not necessarily looking at the numbers, what the exact numbers are. We just want to know if it's going to be negative or positive. So plugging in a -1 here into the second derivative is going to show that the second derivative here, the second derivative will be positive. So what does that mean about my function? My function will be concave up. So I want to put C up. That makes sense. So from 0 to 2, what's a good number there? Well, 1. If I plug in 1, that's going to be a positive 12 being multiplied to a -1. Positive times a negative is a negative, so my f double prime here is less than 0, which says that that's negative. So my function, is concave down, or C down. Make sense? Right, then the number in this interval is just something bigger than 2, so it'll be like 3. 12 times 3 is 36, so it's positive. Times 3 minus 2, that's 1, so that's positive. Positive times a positive is a positive, so that means that f double prime here is greater than 0, which is saying it's positive, so my function, f, is concave up, C up. So what intervals am I concave up? Where I'm concave up, from -infinity to 0, and from 2 to infinity. And the justification, because f double prime is greater than 0 on these intervals. Okay. And I'm concave down from 0 to 2. And what's my justification? Because f double prime is less than 0 on this, since there's only one interval, this interval. Okay? So this is the second derivative test. That's what we're doing here.